Hi, this is Mike Hendrickson from Strata Hadoop World in San Jose. I'm here with Jason Waxman from Intel. Jason, how you doing?
Good. Thanks for having
You
me.
gave a keynote this morning.
I did.
And you kind of talked about the things that Intel is involved with, mostly around artificial intelligence, AI.
Yeah.
Can you unpack the layers that you guys have at Intel around AI?
Sure. It's a very complex subject, and there's a lot of different elements to it. But at our core, we are a data platform company, and when you think about that, there may be many different types of use cases. You might be looking at an autonomous driving car. You might look at a wearable, such as you have on your wrist. They're all producing data. And that data requires compute, and it requires storage, and it requires memory. And those are things, building blocks, that we at Intel have always sort of built. And so we look at various layers to the AI stack. You've got the underlying silicon that drives the performance for AI. You've got the storage and the memory, which we also participate in as well. Above that, you've got libraries that are required to go optimize things such as algorithms for deep learning. A lot of investment that we have there, and then actually providing a platform and a set of solutions that allow others to build on top of it. So you might be familiar with some of our software assets, whether it was the Nirvana acquisition for deep learning or the Saffron acquisition for reasoning systems. They are building blocks that allow somebody to integrate a complete solution. We have a very tight partnership with Cloudera on the data hub side of things, and so we really look at how we put all of these pieces together that ultimately drive a lot of data that requires a lot of compute, and that really kind of comes back to our core.
So at your core, it's interesting, your core is data rather than silicon or chips or machine. It's kind of interesting perspective from an Intel. So as you see IoT and devices and as we instrument the world, is that part of your strategy because you're seeing so much of this in the wild?
Absolutely. Again, our goal is to make sure that if it requires compute or requires storage, and data requires both of those, that we're helping to go enable it. And that really supports our growth. I don't think there's anybody on the planet that does a better job of driving cost-effective compute and cost-effective storage, and that's where our fundamental strength is. But that means that we have to look at all kinds of platforms that are giving off data. And you look at the amount of data that an airplane gives off, or the amount of data that is required to create our medical records. These are all usages that require both intelligent IoT types of devices through a network, which we're trying to help evolve to be 5G, to a data center that's largely built off of Intel Xeon processors. So we really look at these solutions from end to end.
Well, and those solutions, if you look at your industry verticals that you're working with, Intel's done some really interesting projects with companies and different industries. Can you talk a little bit about maybe it's medicine and transportation and other areas that you guys have been working in?
Yeah, we've been working in healthcare and personalized medicine for a long time, and Dr. Eric Dishman, who used to be a part of Intel and is now part of the efforts in Washington these days. He really set this goal to say we really ought to be able to, all in one day, be able to go help diagnose somebody with very, very complex healthcare types of issues. And that means bringing together genomes, it means bringing together electronic medical health records, and creating a personalized medicine. And we know that the real right way to treat very difficult diseases such as cancer is you have to really personalize the approach to your lifestyle, to your genetics, and take a much more targeted type of approach. That requires a tremendous amount of data. So we've been doing a number of different efforts. One, as an example, we were doing wearables to diagnose and help to be able to treat things such as Parkinson's disease. We were engaged with the Michael J. Fox Foundation to help advance some of that effort. We look at the application of deep learning to medical imaging. I talked earlier today about work that we're doing in China to be able to improve on cancer, to be able to improve thyroid cancer detection rates through imaging. We also are looking at how can we bring together the pool of genomes that's being collected. They're all in these silos across industry, and we've initiated what we call the Collaborative Cancer Cloud, a data exchange, if you will, for genomes, an open platform that allows institutions to come together. And it's really by connecting all of those different data sources that we're really advancing the mission toward personalized medicine. So that's just one example.
So do we ever get to a point with healthcare to where we're 100% preventive, so healthcare insurance is not an issue? I mean, are we ever at that? Gonna get to that point?
I would love to get there, but I think over time we will be making great strides. I would love to get to the point where no one ever has to get cancer anymore because you can see the steps along the way and nip it in the bud. But I think we're a long way.
And so AI can take us a lot further in a lot of areas. So one could be transportation. I mean, you know, I look at California. I came from here. I live on the East Coast where we have good transportation systems built.
Right.
Are we ever going to get like that worldwide? I mean, are we ever going to get transportation under control?
You know, there are some amazing projects right now that there's sort of two elements to it. You can tell there's a lot of focus on autonomous driving, a number of announcements. We've been kind of public about some of our work with BMW as an example to go do that. But there also are there are a number of smart cities projects popping up all around the world. I know Singapore, as an example, is really trying to lead the way there. And it's this combination of getting, you know, vehicles that are hopefully safer and can really help manage that overall flow. We're good, but you know, if you've ever been on the highways in Oregon, the whole merging thing is not, you know, great. You could do a lot better if you had, you know, cars that obviously know how to fill in that trailer. That makes a big impact in traffic. But then there's also the intelligent routing, and we're seeing cities put together these networks of smart cameras where they can, you know, on the fly really start to reroute traffic, as a result change the signals, change the lights to really help remove congestion. All of it is just a giant network of cameras and vehicles and other types of devices together. It was going to require a tremendous amount of compute, network, and storage, obviously, to really turn that into an optimal system.
So compute, network, and storage, and also infrastructure and hardware at the base level that you guys have.
By the way, I view it still as, you know, whether you're looking at a smart camera or the compute inside of a car or the compute inside of a data center. It really fundamentally comes down to there's compute required to do some sort of function. It's different, right? I may be looking at trying to decide, is the object that entered a road a ball? That's the compute that's happening at the car. And then I may be aggregating all of that into the data center to really analyze, is there a pothole on the road and do we have to reroute traffic as a result? But all of it winds up being compute just distributed across different devices.
So Jason, if you and I were to sit down here a year from now and have the same discussion, what would you like to say is on the roadmap for Intel that you guys have accomplished by the time we have that discussion? What is in your near future? And then take a step forward even from that, the year after that. What would you like to say you guys are going to be doing on that journey?
Yeah, so I think number one is we are on the path to deliver the best AI platforms in the industry, bar none. And what I mean by that is it has sort of two attributes. One is that it delivers the best performance per dollar. As you know, a lot of these solutions are compute intensive, and so to be able to train systems, we want to provide breakthroughs, and that's going to allow much more breakthroughs in the actual science itself. So we have to deliver the best performing per dollar platform on the planet. The second is we want to be able to create a number of open platform initiatives that really allow innovation to occur. And obviously, intelligent transportation is one of those areas, and autonomous driving cars. Another one would be in healthcare. Particularly a big mission for me is I really want to find a way to aggregate all of the genomes that we have across different institutions and allow drug or pharma companies or other institutions to be able to access that data and to drive innovation. So I'm pretty confident that we'll be talking about our updates on that next year.
In the next year.
Yeah.
And then take it out. Let's say, what is your dream? How big can we dream, and when can we get there?
Yeah, you know, just taking, for example, medicine for a little bit. I think delivering that best platform, we're going to see better diagnoses of images. We're going to see more remote diagnostic types of solutions that'll be in houses. And as I mentioned, trying to bring together the pool of electronic medical health records with genomes. Those are things that'll happen in the short term. It's really the bringing together of all of that that really will lead to personalized medicine. And I think we're still on the track that in the next 3 years, we're going to see solutions that will be rolled out by healthcare institutions that will allow for much more specific treatment for you and me to have a much better quality of life. That would be a great thing.
So Intel Inside may have a different meaning.
Yeah, hope so.
Very good. Thanks,
Hey,
Jason.
thank you very much for your time.